Welcome back students to the chapter Chemical Bonding and Molecular Structure for class 11. Today we are going to see about Lewis dot structure of some more molecules. So in the last part we have seen how to draw Lewis dot structure. Especially we have seen the examples of carbonate anion and ozone. Here we are going to see some more molecules in this part. So Lewis dot structure for to see some more examples here. First we have hydrogen. The peculiarity of hydrogen is that its stability is not octet, it is doublet, as we have seen in one of the previous parts. Hydrogen etra electron madi, it requires only 2 electrons for stability. So each atom requires only 2 electrons for its stability. Whereas in the case of other molecules, they need octet, they need 8 electrons. Whereas in the case of hydrogen, it requires only 2 electrons. So accordingly, we have modifications in the formula in which we have seen. So in the last part, we have seen that we have seen the formula OE, which means that the electrons required for octet minus electron required the available valence electrons, isn't it? So electrons required for octet minus available electrons, that is VE. Clear? So here there is a modification. Hydrogen octet venda, what it requires is doublet. So I have changed the notation to D subscript E minus V subscript E by 2. So here if you are looking, you will see that there are 2 hydrogen atoms. 2 hydrogen atom. ഓരോ ഹൈഡ്രജൻ ആറ്റത്തിനും 2 ഇലക്ട്രോൺ വേണമെങ്കിൽ if each hydrogen atom, there are 2 hydrogen atoms, if 2 hydrogen atoms requires 2 electron, then what will be the value of DE? Will be equal to 4. ഓരോ ഹൈഡ്രജൻ ആറ്റത്തിനും 2 ഇലക്ട്രോൺ വേണം. അങ്ങനെ 2 ഹൈഡ്രജൻ ആറ്റം ഉണ്ട്. So the value of DE will be 4. Clear? And actually this hydrogen atom has only 1 electron. So there are 2 hydrogen atoms, so VE, that is available electron, will be 2. So 4 minus 2 will be the value. So D is taken because for hydrogen it is doublet, not octet. Clear? So if you are substituting the values for D and V, what we will get? So how did we get the value 4 here? Because for doublet, each hydrogen requires 2 electron each. Clear? And for the in the case of available electrons, each hydrogen have only 1 electron. So 1 plus 1 will give 2 electrons. 2 plus 2 will give 4. 4 minus 2 divided by 2. This is the formula which we have learned in the last part. So what will be the answer here? Will be 1, which means that there is only one bond pair between the 2 hydrogen atoms. So if I draw it, it will be like this. So hydrogen H, single bond H, and we know that VE value that I have seen here is the available electron. So that is the available electron. Now this hydrogen has 2 electron and this hydrogen has 2 electron. Both are being shared. There are no lone pair of electrons. Clear? അപ്പം 2 ഹൈഡ്രജനും വേണ്ടത് എന്താണ്? ഡബ്ലറ്റ് ആണ്. So this hydrogen and this hydrogen requires doublet. So in that case, hydrogen is having now 2 electrons, this hydrogen, and this hydrogen is sharing that 2 electrons, so he is also having that 2 electron, that pair of electron. Next is oxygen. So in the case of oxygen, it is not doublet, it is back again to octet. So in the case of hydrogen, we will first write it. In case of oxygen, we have for one oxygen we need 8. So in that way, what will be the required amount of electrons for octet? It will be 8 plus 8, 16. So if I write it like this, so OE will be equal to 8 plus 8, that is 16, and VE, how much electron is available with one oxygen atom? It is equal to 6 plus 6, that is equal to 12. So I have got the value OE and VE. So I have value for OE and VE. So with those values, I will get OE minus VE divided by 2. OE is 16 minus VE is equal to 12. That's the number of electrons that each oxygen atoms, valence electrons. So each atom is having 6 valence electron. How did we get the valence electron? Group number 10 minus here. So from the group number you minus 10. So group number is in order to get that 16 minus 10. So each oxygen atom is having 6 electrons. We have 2 such atoms, so it will be 2 into 6, that is 12. 16 minus 12, that is 4 by 2. That means we have 2 bond pair. So while drawing, I can have 2 bond pair between the 2 atoms. 2 bond pair varachu kazhinjal, each oxygen, after drawing 2 bond pair, each oxygen is having now 4 electrons. 2 pair of electron means 4 electrons. For him to complete the octet, he requires 8. So I have placed remaining 4 electrons as lone pair. Same is the case with this oxygen. Oxygen 4 electron evident. Again he requires another 4, that is placed as lone pair. Clear? So the available electron was 12. So if it is 12, I should count and see whether I have to verify this, whether it is correct or not. So it is 1, 2, 3, 4, 5, 6 pairs of electron, which means 6 into 12, 12 electrons. So it matches perfectly and is verified. Okay, next, NF3. So again, these are all the atoms that requires octet. There is no hydrogen here or helium here. So they all requires octet, which means that there are 4 atoms. In order to attain octet for each, it requires 8 electrons. So the total number of electron OE will be 32, and valence electron, if I am calculating the valence electron, so OE will be 32, and what is VE? V is 26. How did we get VE as 26? Let's calculate that. So in the case of fluorine, each fluorine has 7 electron. Each fluorine has 7 electron. So 7 into 3, we will get 21. And in the case of nitrogen, it has 5 electron. So when you add 21 and 7, what will be the result? Result will be 26. Okay, so that's how I got the valence electron 26. Total valence electrons in this molecule. There is no charge for this species, so the available electrons is 26. Clear? So what will be the bond paired number of bond pair? That is 3. So now I am going to write the skeleton of the molecule. So I have central atom nitrogen, which is less electronegative. So when you compare the electronegativity, നമ്മൾ നൈട്രജൻ്റെയും ഫ്ലൂറിൻ്റെയും ഇലക്ട്രോനെഗറ്റിവിറ്റി കമ്പയർ ചെയ്യുകയാണെങ്കിൽ electronegativity of nitrogen is less. So nitrogen will play as the central atom. Nitrogen will be the central atom. So let us try to draw the skeleton. It will be like this: nitrogen and the 3 fluorines surrounding it. Now I have 3 bond pair. I drew that 3 bond pair here. Now in the case of nitrogen, if I look into the case of nitrogen, it has 3 pairs of electron. It requires 1 more pair. So I have drawn it over as a lone pair. And for fluorine, it has only 1 pair, 1 bond pair. So remaining 3 pairs are drawn as a lone pair. For this fluorine also, it has only 1 bond pair, so the rest is drawn, and the same is with this one. Clear? So this is how to find or to draw Lewis dot structure. Clear, I guess. Now in the next slide again we will see few more examples. So let us see few more examples. First we have HNO3. So what is this molecule? It is very familiar molecule. It is nothing but nitric acid. HNO3 is nitric acid. So one thing what we have to be familiar with when you are dealing with this molecule, that you should first have a knowledge about the skeleton of this molecule. So like NF3, we have nitrogen in the center, so I will draw it. We have nitrogen in the center and oxygen surrounding it, 3 oxygen surrounding it. Clear? So what was the rule? You have to place least electronegative in the center. But if you look into the molecule, you will see that least electronegative is hydrogen. But while stating that rule, we have seen we have to we should not consider H if that molecule has H, because H can never be a central atom. Why? Because it can form only one bond at a time. Hydrogen can form only one bond. So central atom must be able to bind or bond more than 2 times, more than 1 time. It must be able to bond more than 1 time. So hydrogen, since it is bonding only 1 time, it can form only 1 bond. It cannot be considered as the central atom. So if there is hydrogen, you just forget about it and look for the next less electronegative. So among nitrogen and oxygen, അടുത്തത് ആരാണ് less electronegative ആയിട്ടുള്ളത്? It is nitrogen. So I placed it in the center and oxygen is surrounding it. And if that is the case, then hydrogen must be bounded to more electronegative atom. So here, which is more electronegative atom? It is not always the same, but in the skeleton of nitric acid, hydrogen is bound to oxygen. So I will write hydrogen here. It's bonded to oxygen. Clear? So why it is bonded to oxygen? So as we said, this is an acid. Nitric acid is an acid. This is a special acid which is called as oxy acid. എന്തുകൊണ്ടാണ് ഇതിനെ oxy acid എന്ന് വിളിക്കാൻ കാരണം? First of all, we should know what is an acid. What is an acid? You might have learned in the lower classes. Molecule that releases H plus in the solution. ഏതൊരു molecule ആണോ solutionൽ H plus തരുന്നത്, that compound is called an acid. Clear? And in this compound, this HNO3 is giving H plus, but that H plus is given by oxygen. So hydrogen is bonded to oxygen and oxygen is giving you the H plus. So this acid is called an oxo acid or oxy acid. So this is how to remember. So this is an oxo acid. So H should bond to oxygen and all the oxygen should bound to nitrogen. So that's a skeleton that you have to remember. So we will proceed further to calculate the formula that we know. Now why we have the number 34? Because hydrogen requires 2. So I will write it. Hydrogen requires 2, nitrogen requires 5, and oxygen nitrogen requires 8 and oxygen requires 8 into 3. So total number, if you add them up, you will get 34. That's how we get the octet required. Except for the case of hydrogen, it is doublet. So all the 3 requires 8, that is 32, and hydrogen requires 2. So 32 plus 2, 34. And in the case of the available electron, so I will write at the bottom. So like this. It has 1 available, this has 5 available, and this has 6 into 3 available. So if you add them up, you will get 24. You will get 24. So how many bond pair will be there? 5 bond pair, which means that I can draw them like this: 1, 2, 3, 4. 5 bonds here. Now there is 4 bonds here. Now one is left. Where should I write that one? I am not expected to write the second bond here. I should not write here because here oxygen already have 2 bonds. Maximum number of bonds that oxygen can form is 2. So oxygen already have that 2 bonds. So if I am going to write the 5th bond, either I can choose this one or I choose this one. Clear? So either I can choose this one or choose this one. So we will see. You can see that single bond, single bond, single bond. I have chosen this one for keeping the second bond. Now look into the electrons. Here hydrogen has 2, fine. Here oxygen has 2 bond pair, so it requires another 2 pair. It is given as a lone pair. Nitrogen has 4 bond pair, so fine. Oxygen again has 2 bond pair, 2 lone pair is given. Here oxygen has only 1 bone pair, so 3 lone pairs are given. So this is how to write the Lewis dot. Next compound is carbon monoxide. So carbon monoxide, I am going to see the formula and substitution. So two atoms means 8 into 2, 16 electrons is required. And what does it have? Oxygen has 6 and carbon has 4. So total of 10 electrons, 4 plus 6, 10. So if taking, you will get 3 bone pair is required. So carbon and oxygen is written and 3 bone pair is written between them, which means that carbon requires 1 more pair. So lone pair is given for carbon and lone pair is given for oxygen also. So thus the octet is complete in the case of carbon monoxide. Next is nitrite anion. So nitrite anion, again we will look into the formula, and it is OE minus VE, and if you are substituting we get values like this. Let us see how we got the values. So I have 3 atoms. I have three atoms here. So if 3 atoms requires 8, it will be 24. 3 into 8, 24. And how did I get the value? 18 here. So that also I will write. In the case of nitrogen, I require 5, or the available electrons is 5. For oxygen, that is 2 into 6, which means 12 plus 5 is equal to 17. And already the molecule is having a charge, negative charge. So that negative charge is added. So total charge, available electron is 18 electron. That's given here. Clear? So there are 18 electrons. 24 minus 18, 6 by 2, which will be equal to 3. 3 bone pair is there. So again nitrogen is placed in the center and oxygen on the either sides of nitrogen, and 3 bones are distributed like this. And the pair of electrons that is deficient to get octet is distributed as lone pair. Now what you can do is you count the number of electrons. So since it is 18, there should be 9 pair of electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pair means total of 18 electrons. And you place them in a square bracket and give the negative sign, so that you can denote this the charge of the. Clear? The last one, again you should know the skeleton of this compound. Skeleton of this compound will be like this. So carbon and so skeleton will be like this, C, and we have 2 O's like this, and one H is attached to O and the other H is attached to carbon directly. So one H is attached to oxygen and the other H is attached to carbon. Clear? Now we are looking into the formula and I'm substituting. How did I get 28? That's the question. So we will see. This is 2 and this is 2. That means 4 required for hydrogen for doublet, and 16 required for oxygen for octet. So that means 16 plus 4, 20, and 8 requires, so it is 28. And how many valence electrons are available from this compound is, this is 1, this is 4, this is 6, 6 and 1. So you add them up, you will get 18. Clear? So if I am substituting, I have 5 electrons. Now I am 5 base pairs, so I am distributing that base pairs like this: 1, 2, 3, 4, and the 5th pair must be placed only if oxygen is free. If oxygen is bonded to something else, I cannot place that, so I am placing here between carbon and oxygen. And the rest that is deficient in electron octet is placed with lone pair. For this oxygen, it has only 2 bone pairs, so 2 lone pairs are placed. It has only 2 bone pairs, so 2 lone pairs are placed. For rest of the atoms, everything is satisfied. So this is how to draw Lewis dot structure. Clear? Thank you.